My name is Tomasz Klasa from the Polish Information Processing Society, and we're going to talk with Mr. Rick Glick, right?
Right, thanks. Nice to meet you, Tomasz.
Today you told us about analytic databases and showed a whole list of issues that should be solved to improve the quality of analytics. One of them seems to be how to replace relational databases.
Well, actually, I didn't mean replace, but rather complement it with new data types, new analytics, extend the SQL language, but also do things that are non-relational. You know, work with hierarchical data, for example, or other less structured data where you put structure on it query time versus having a rigid structure when you first model the data.
Okay, I said replaced because I think there were at least few attempts to replace the relational databases, and for instance, the object databases.
Yeah.
And
I don't believe that relational technology will ever be replaced, and I don't think it should. We have a set of standards that have worked better than anything else, be it all not perfect, right? But SQL is a fairly rich language, and as long as we don't, keep it in its current form and extend it, standards are good, and when dealing with massive amounts of data, it's a fine paradigm. It's a fine way of interacting with data.
Mm-hmm. Okay, and maybe the two other issues are, I would say, very, very hard to cope with. It's scale and the level of sophistication of analysis. I strongly believe it will never stop to go up. But, is there any real stop point?
Well, there's no stop point, but we have to get better in all dimensions over time. Mm-hmm. And if you define scale as not just simply being volumes, but scale in terms of compression of time, in terms of number of users, in terms of managing large amounts of resources as well as data, then no, the problems are endless, but thank goodness, because that's what keeps us employed and having fun. But truly, you're right, but we can do a lot of things better than what we've done in the past surrounding scale too. We can work on problems of uneven data distribution and skew, and have mitigation techniques that people have talked about and discussed but never really done. So there's plenty of room to improve what we do today, and you're right, it just keeps getting bigger and better.
Yeah, and when they keep growing, getting bigger, and more sophisticated, at the same time, they become more and more hard to use. Because if there are so many more options, how to make them easy to use, easy to install, easy to configure, right?
Well, and there are attempts at dealing with that. I'd argue that cloud is kind of an attempt to take the unnecessary drudgery out of provisioning and working with the administrative side of the database and letting you get on to just the analytics side. And I think as an industry we need to drive out complication. Not give people every knob and dial to turn to sub-optimize everything, but have a pragmatic approach where you can do really powerful things fairly simply and easily. So extending the SQL language is part of that, for example. You extend that so that it has new powerful constructs that aren't traditionally relational. So absolutely things get more sophisticated, but that doesn't necessarily imply more complicated. It's our job to kind of drive the complication out so we can actually handle more sophistication.
Yes, it sounds like even more layers for us IT specialists to cope. Mm-hmm.
Yeah, it's our job, not the people who run the analytics and do the analytics. It's our job, the folks who come up with the systems to remove complication by adding more sophistication and more elegance to our designs and the things we work on.
You also said about the project Redshift. it's your project, right?
Well, I was involved with ParaXL, which is the code base for Redshift. So ParaXL was a massively parallel shared nothing columnar analytic database. And it's still in existence now by a company called Actian. But the underpinnings for Redshift and the technology, they bought the technology from ParaXL, and it became Redshift. So it's primarily ParaXL.
Okay, so where's the improvement? What's the most significant improvement in Redshift, right?
Well, there's two things. One, it was a pretty good analytic database that they took, but the other is just taking all that administration use out, making it easy to provision, making it easy to grow from 10 nodes to 100, from 10 terabytes to a petabyte of data. You know, they've taken all that administration and complexity out of it for the end user, so you can focus on your data mining and your analytics. So Redshift is great both from a pure columnar parallel database perspective and from a deployment perspective.
Okay, so it sounds like something totally perfect, but is there any limit, bottom line limit, to implement Redshift?
Oh, sure. So if the data doesn't originate on Amazon or on EC2, loading petabytes of data is kind of a difficult thing to do. Plus, it's still very much relational, so it has a very rigid schema, and you have to optimize the schema, and you have to figure out your distribution keys, and there's a lot of database admin work with it. The analytics it does are primarily simple aggregations and SQL. It doesn't have a lot of the extensibility features, and I think it supports scalar UDFs, and that's the only form of UDF it supports at the moment. And so it's good underpinning of technology, but it has a lot of room for improvement too, and I know they're working on it.
Okay, because it relies on the cloud model, right? Mm-hmm. One of, I'd say, the biggest advantages is the flexibility of the model, right? So it can be applied in smaller systems and bigger ones. Where's the smallest level, I would say, it would be profitable to apply it to?
Well, the thing about, and I don't work for Amazon or really know that much about their model, but what's kind of nice is that an individual could have an instance of Redshift on a single node and do their work, and it doesn't cost that much because you're charged for the resources you consume. So a large enterprise can have a petabyte of data, or an individual can have gigs of data, and it scales between those extremes, and you only pay for what you use. So even I can afford Redshift, and I can't afford much.
Okay, so thank you for the really short interview. And
well, thanks. It's been a pleasure.